When you study the Aristotelian square of opposition, you study, among other immediate inferences, contraries. So, you might ask, what are contraries? Well, contraries are inferences between two universal propositions. Now, I'm going to assume that you are already familiar with what each of the four proposition types in categorical logic are. Namely, I'm going to assume that you know there are two quantities, universal and particular, and two qualities, affirmative, negative. Combinations of these make up the four proposition types. In addition, I'm going to assume that you understand already what existential import is. In other words, you know that the traditional or Aristotelian interpretation of the universal proposition assumes at least one member of the subject class. Lastly, I'm going to assume that you are familiar with the Venn diagramming method of providing a visual presentation of a proposition's logical structure. The assumption of existential import is what allows for several immediate inferences around the so-called square of opposition. Two of these, as I pointed out a moment ago, involve inferring one universal from another. First, let's review our universal propositions. All S are P. The Venn diagram shows us that the shaded area, that is the area of S outside of P, is empty. There's no there, if you will. You can't put anything there. Whatever S's there may be, and we're assuming there is at least one S, hence the circled red X in the middle of the two circles, that is in the overlap area between S and P, are all members of the P class. Also, no S or P tells us that every S is not a P and vice versa. In other words, S and P are mutually exclusive categories when the proposition is a universal negative. Once again, however, we assume at least one member of the subject class. Now let's talk about contraries. Universal propositions are contraries. We can make a limited inference from a universal to its contrary. More specifically, if we know a universal is true, its contrary must be false. We may not, however, validly infer the contrary of a false universal. In other words, the two are not contradictories. It's not the case, then, that when one is true, the other must be false, and when one is false, the other must be true. That's the definition of a contradictory set of statements. So, although if a universal proposition is true, its contrary must be false. If the universal proposition is false, its contrary is undetermined. In other words, the truth value is undetermined. On the other hand, we know when an inference is valid that the truth value is determined. It's forced. Take a look at the upper left and upper right corners. The true universal affirmative yields a false universal negative. So the contrary of a true universal is a false universal. The contrary of a true A proposition is a false E proposition. Now drop your eyes down to the bottom of the screen. Please note that I'm not in this latter case, in the bottom half of the screen, I am not attempting to display the square of opposition. Instead, I'm simply trying to give you on one screen, on one visual, the move from the A to the E and the move from the E to the A when the premise or the first proposition is true. So what you have is the following. If we were to blend them, you would have true A to false E, true E to false A. Let me show you. Here is the appearance of the universal affirmative and the universal negative in their standard spots on the square of opposition. Notice we have a true universal affirmative. It yields a false universal negative. So also a true universal negative yields a false universal affirmative. Here are some ordinary language. Here's some ordinary language examples. The universal negative, no squares are circles, is true. Consequently, the universal affirmative, all squares are circles, is false. Similarly, the universal affirmative, all dogs are animals, is true. So, the universal negative, no dogs are animals, is false. Now we've got another set of Venn diagrams that are meant to show us that a false universal does not determine its contrary. In other words, a false universal could yield a true or a false contrary. Even saying that a false universal yields a contrary is misspeaking. It's really not accurate. At the very least, it's not precise. We simply cannot determine what a contrary is when the universal is false. So we can see in their traditional spots on the square of opposition that the false universal yields an undetermined contrary. Here are some ordinary language examples to help you wrap your head around what you've just seen from the Venn diagrams. The blue are the examples that start off with a false universal negative, and the green are the examples that start off with a false universal affirmative. So notice that a false universal negative does not guarantee that the contrary is true. It doesn't guarantee that the contrary is false. The examples show us that sometimes the contrary is true and sometimes it's false. I hope this tutorial on contraries is helpful to you as you continue your study of categorical logic.